Hi guys, this is Andrew.
This is Richard.
So for our working with electron final project, we decided to build a cell phone 4G signal jammer and we name it as Be Quiet in Public. For our introduction part, cell phones have become an essential gadget in our daily life, but it will be annoying when it used to in inappropriate places like hospitals, schools, theaters, and so on. So for this purpose, cell phone jammer circuit is used to block the signals received by the cell phones, causing them to work properly. But in some countries, using jammers are prohibited and will be personalized if you do. So we make a reverse version of it. And we can learn from the jammers when we use in the exam. It has large size and with high power and can block other signals and interferes with normal operation of the public places. So we decided to make a small size of the jammer only blocking the 4G signals. And this is what we are working on.
Okay, here is the schematic and PCB design. According to the Maxwell's equations, we draw the connection between electricity and magnetism, deducing that the light is also a kind of electromagnetic waves. With the coexisting of the electric fields and the magnetic fields, the radio waves come into being. Moreover, with different certain values of wave frequency, different corresponding electronic devices can detect each other. The working of this circuit starts with feeding a random noise signal as the input. The signal is fed to capacitor C1 to remove the DC components in it. The signal is then fed into an RF oscillator built around a high-frequency NPN transistor T1. Besides, altering the position of the trimmer will vary the output frequency. Capacitor C4 was used to produce sustaining output frequency oscillations, and the capacitor C5 was used to remove the DC components from the final output RF signal. You can use an RF antenna or an automobile's antenna along with this circuit for signal transmission. This circuit has a range of about 20 feet radius and is capable of queuing cell phone within that. Let's go on.
However, when we finish soldering our component into the project, we find that it doesn't work. The phenomenon is that LED is still shining, but it doesn't block the signal. So this is the different antennas we found in the internet. And we think the antenna is the key component to success of the project. The main influencing factor of the antenna is the number of the turns, the material, the shape, and the length. And the longer the line, the lower the frequency point. And based on what we discovered, we made three different assumptions. The first assumption is about the directivity of antenna. The second one is about signal strength. And the third one is about the frequency of resonance. So let's move on to the directivity of the antenna. We think the router's antenna is directional. The signal in the direction parallel to the antenna is the strongest, while the signal in other directions is weak. Therefore, the router's antenna will be turned into different directions to maximize the signal range. The number of the antennas also affect the signal strength, but because we are designing a circuit that only uses one antenna, and based on the study and research we find so far is that antenna works best when it is straight up. But when we turn the antenna to straight up, it doesn't work. So we move on to the second stage. It's about the signal strength. In the direction parallel to the antenna, you can get the strongest signal. We used the potato chip package to simulate the random because the random was able to enhance the signal, but it failed in the end. And the last assumption we made is that it's related to frequency of resonance. So after our research, we found that the 2G signal is about 850 megahertz, the 3G is about 200 megahertz, and the 4G is about 2500 megahertz. In the experiments with the circuit, we tend to place the different types of antennas to jam different types of signal, which are the 3G antenna, the 433 megahertz antenna, and the handmade antenna with 24 AWG wire with 15 turns. But after we soldering the three different types of the antenna to the PCB board, it doesn't work as well. So for the first step, we will change the materials, the turns, and the length of the antenna to discover what's going on next. And hopefully our project will successful somehow. And this is the resource we used in our presentation. Finally, this is all of our presentation. Thanks for listening and take care wherever you are. This is Andrew. Bye.
This is Richard. Bye.